In last two lecture, we have discussed about the micro machining process. In last lecture, we have started about the photolithography. Uh, this is a part of the micro machining process, and these two lectures are available on the YouTube channel of the Engineering College Banswara. So you can refer all the lectures that are available on the Engineering College Banswara YouTube channel. We will continue about the photolithography process. So it's a temporary coating of photoresist on wafers, basically. The single layer that is called as the wafer. So transfer design pattern to the photoresist. So first we have to produce the pattern that we want to produce on the actual surface of material. So we will use the UV light. We will discuss the next most important process in IC fabrication. So we will not discuss all the component and process in detail. We will discuss the principle and the actual machining, how the machining process can be done. If we consider the time of the manufacturing process any component, so 40 to 50% total time that should be consumed during the wafer process determines the minimum feature size. This schematic diagram or overview of the photolithography. Here we have a light source, that is the UV light source, that is transferred to the condensing system. Then it is transferred to the mask through imaging system. Here we have image and developed resist and a substrate. So here we have two types of system. You can see that we have a pool of the liquid basically, and we have system that if we expose that liquid into the UV light, so it will solidify basically. Now what will happen when it solidify? But the condition is that wherever that light goes, that part is the only solidified, and rest of the area should be as it is. Okay. Now what we are doing, we are using the here polymer type material, and we are applying the design pattern, so that light should travel only through the space which is already provided into the wafer. Okay, so that area will solidify and the rest of the area kept as it is. So lithography consists of the patterning subtract by the employing the interaction of the beam of the photons or particle with the material. Photolithography is widely used in the integrated circuit manufacturing. So as we have discussed, this is the special type of manufacturing system basically used in the electronics companies. The process of IC manufacturing consists of the series of 10 to 20 steps or more, called as the mask layers, where a layer of material coated with resist or pattern then transferred into the material layer. Photolithography system consists of a light source, a mask, and an optical projection system. A photoresist are a radiation sensitive material that usually consists of a photon sensitive compound a polymer backbone and the solvent. So as we have discussed that we have a system that we have a pool of the liquid that get solidify if it comes in the contact with the UV light. Resist can be classified upon this solubility after exposure time, positive and negative. So solubility of exposed area increases, negative that solubility of exposed area decreases. Main application is IC patterning process. Other application printed electronics board, nameplate, printer plate, and so many applications. Photosensitive material. These are two types of classification: negative and positive. In negative photoresist, we have it's insoluble after exposure, becomes soluble after exposure. So, a simple thing. Suppose we are supplying the UV light on the polymer pool, it will solidify. It means what? It is positive photoresist, and if it will not solidify, so it is known as the negative photoresist. When developed the exposed part dissolved. Okay, when the develop the exposed part dissolved. Here unexposed part is dissolved, so you will get the actual part, and here you either the developed part is dissolved, exposed part basically. Cheaper and better resolution. So actually you have to identify, suppose you want to create a hole for a solid part, so from that you can select the negative or positive photoresist process. Here you can see this diagram that how this process is carried out. In photoresist, here we have substrate, here mass and reticle. Here we have UV light. So you can see that we are passing UV light from this mask. So we have two conditions that we can solidify this green part, or we can solidify that blue part. So it's depend upon the negative photoresist or positive photoresist. Here UV light will pass from this green area, so you can see that green area will solidify. This is known as the negative photoresist. In second case, this rest of the part, that blue part, will get solidified and the rest of part will dissolve. So this is the photoresist process for the positive. So you will get the different result after the development process. As we have discussed, some composition like polymer, solvent, sanitizer, additives, polymer, solid organic material transfer, design pattern to wafer surface. We will not discuss in detail. So this disadvantage of negative photoresist, that polymer absorb the development solvent. So a poor resolution due to PR swelling. Environment and a safety issue due to main solvent acetylene. So this technology has some disadvantage, like you will not get the good surface quality or surface finish compared to the other manufacturing process, and it also has some environmental issue. So you have to take care about this process during the selection. Expose. Now we will discuss about the positive photoresist. Expose for dissolve in the developed solution. Image the same that on the mask. High resolution and commonly used in the IC fabrication. So this is the comparison between the positive and negative photoresist. Energy from the light dissociate the sanitize and break down the cross links. We are not discussing in detail. So this is a summary, you can refer one by one, but at this point it is not required. Just you have to get some knowledge or idea about the process, how this manufacturing process can be done. Okay, thank you.